Today we're going to explore how to work with nodes inside Houdini using Python. Be sure you have selected the technical desktop because this has all the panels we'll be using today. It has the tree view, the Python shell, and the network editor, as well as the parameter panel, which we'll use a little bit. So with that in mind, the first thing I'd like to do is look a little more closely at the Python shell. The first line of the Python shell lets you know what version of Python you're using. I'm using Houdini 18.5 right now, and as of Houdini 18.5, Python 2.7 is the version of Python being used. I know SideFX is in the process of upgrading and catching up and using Python version 3. And so if you're watching this and you're using Houdini version 19 or later, it may say Python 3. But don't worry, all of the Python code that I write today will work with Python 3. The next line lets you know what version of Houdini you're using. But more importantly, it also lets you know that the HOU module has been imported. The HOU module is the library that gives you access to all the functions and classes and modules that you need to be able to control Houdini using Python. In particular, the function we'll be using a lot today is the node function. Functions start with lowercase letters, and you can tell it's a function because there's an F icon next to it. With an open parentheses, it will give you a little bit of help documentation and some examples on how to use this function. And you want to be careful because if you type in capital N for node, you will find that it's node with a C icon next to it. That's because this is a class, it's not a function. Open parentheses, you'll see something different. This is the constructor for the node class. So you'll just want to be careful that it is case sensitive and lowercase node and uppercase node are different from one another. With that in mind, let's make a quick test geometry and then start using Python to explore the network. So I am going to control click the box and we now have a box geometry node. Let's rename this box demo. And when we double click and go inside, you can see right now there's just a box node. Well, we're going to do a little bit with this. First is we are going to add a color node, Shift Enter, and color the faces of the box yellow. Next, we're going to split off from here and add a polywire node. And what that does is it puts cylinders along the edges of the polygon. But they're a little bit large, so let's just decrease the radius of this. There we go. And then we are going to add another color node and make the edge tubes, the edge wires, how about a bright red? Next, what we do is take these two nodes and we're going to merge them together and then add a null output and call that output. There we go. So we have a network here with 6 nodes. Now let's return to the tree view, and I want to point out a few things. The tree view starts with your root node up here, and there are 8 kind of contexts, if you will. You know, for working with tasks, top operators, stage, the new USD and LOP operator, place. But we're working with the OBJ context. That's where you create your scene, all the objects, lights, and cameras for your scene, if you're still using lights in this context. Here's the geometry. And here are the 6 nodes. You can see the 6 nodes that we use to construct this red and yellow box. What the tree view shows you is the parent-child relationship between all the nodes in your project. So underneath the root node, there are these 8 standard contexts as of version 18.5. The number of contexts and what you see here will vary from version to version. They've been adding and removing things over the years. Inside the OBJ, or the scene context, there's a single geometry node. And when we expand the geometry node, we see that it has 6 child nodes. So the box demo node has 1 parent, OBJ, and it has 6 children. What you cannot tell from the tree view is how these 6 nodes are connected to one another. That's what the network view is for. So now, using Python, what I would like to do is get a hold of some of these nodes and allow us to explore both the tree view and the network view using Python. First, let's get the OBJ node. We call the Houdini module the node function and just type in the path to it. And you can see it gives us a nice little auto-suggest. It does let you know what children there are underneath the OBJ node, but for now we just want the OBJ node. If you display it, it is just a node. There's not much to it. But what I would like to look at is what is the parent and what are the children of this node. If you collapse this, you can see the OBJ node should have one parent and one child. And there are methods for doing just that. There's a parent method that shows the parent of this is just the root node, which is a /. And then you can also call the children. And this node has only a single child. This is an important thing to remember. Each node has one parent, but it can have multiple children. To see that, let's now grab the box demo node. So we have box demo is going to be, we'll call the node function and type in the path to it, obj/box demo. The parent of the box demo should be obj, and when we call the children method, there should be 6. So if we call box demo and call the parent method, it returns the obj node. Now for the children node, since there's more than one, we're going to loop over them. So for child in box demo children, let's go ahead and print the child. And there you go. It displays the 6 names of the 6 child nodes for this box. So that's what the tree view shows you. It shows you the parent-child relationships between nodes, and you can access them by calling the parent method and the children method. Notice parent singular, children plural. Once you have a network, let's take a node inside the network and explore how you can see the connections between those nodes. We'll start with the box node. We'll get it once again by calling the node function and typing in the path to the node we're interested in. Now, the connections between them aren't called parents and children. They're called inputs and outputs. So for the box node, there's no incoming node. There's no inputs, but there should be 2 outputs. Let's see if that's the case. So if we call the inputs method, there's nothing. Now, if we take the box and call the outputs method, you will see that there are 2 nodes, and it gives you the path to those nodes. Color 1, which we see here, and then there's the polywire node. So that is how a network is connected over here. Each node has inputs and outputs. So the nodes in the network editor have inputs and outputs. So to recap, for tree view, parent and children, and in the network editor, it's inputs and outputs. Let's look at the merge node. That actually has inputs. So to get the merge node, once again, we call the node function, type in the path to it, and let's look at the parents. Whoops. Let's see, it's easy to fall into that trap. So let's look at the inputs, and there are 2, color 1 and color 2. And we can see that that's the case. The only 2 nodes being wired into the merge are the color 1 node and color 2. Now, the outputs should be this null node called output. So if we take merge and call outputs, we see it is indeed the null node named output. Notice inputs and outputs are both plural. And over here, children is plural, parent singular. With that in mind, what I'd like to do is delete this geometry and build a new one using nothing more than Python. So what we're going to do is we're going to create a sphere and a box, give them different colors, and then display them using nothing more than writing Python. We're actually not going to use the shelf tools, and we're not going to come over here and press tab and use this pop-up with all of the different nodes available to us. So the first thing we need to do is create a geometry node. So let's just call it geo. And how do you make a node? You can't just call hou.node. You can't just call the node constructor. You get an error. It says the class is abstract. If you're not a strong software engineer, that may be a little bit confusing to you. Essentially, what this means is that you have a class that you're not intended to make yourself. And so you may be tempted to think, well, node is kind of a generic type class anyway. What I want to do is make a object node or a SOP node. If you call object node, you get an error again. Same error, no constructor, class is abstract. Well, what about a SOP node? A surface operator, same thing. The point being, the way they want you to create nodes inside Houdini using Python is they want you to take the node that's going to be the parent and then create the child. That way, it's guaranteed to appear somewhere in the tree view. If you just created a node and it had no parent and no children, where would they display it here? There would be no place for it. And so this is a way to guarantee that your nodes stay organized. So we want to create our geometry node inside the obj context. So let's get the obj node. Actually, we already have it. So here's how we create a node. We're going to call it geo. We're going to take the obj node and call create node. Now, when you create a node, they want to know what type of node you want to make, and then optionally, you can specify what the name of the node should be. So let's do that. Let's make a geo node, and let's give it the name GeoDemo. There it appeared both in the tree view, and it appeared in the network editor. So let's go inside here, and now we're going to make the 6 nodes that we need. Let's see if that's correct. We're going to need a sphere, a box, 2 color nodes, and a merge, and a null output. So we're going to have 6 nodes. So let's go ahead and do that. So for box, what is going to be the parent node of the box? It's not going to be obj like we just used. The box and all the nodes that we make now are going to go inside the GeoDemo node. So that's the parent. So we need to take the geo node, call create node, and make a box. And we can give it a name. Let's just call it box. Otherwise, it would default to box 1. There we go. We made a box. And if you dive into the GeoDemo node, you'll see it's there. Let's go ahead and create the last 5 nodes. So we're going to have a sphere. Its parent is going to be the geometry node. So create node, sphere. And it just called it sphere 1. We didn't specify a name this time. So here we've created a sphere. Now we need 2 color nodes and a merge and a null output. Let's call the first color node color box. And its parent is also going to be the geo node. And it's a color node. And the node name will be color box. Now, it appeared over here in the network editor, but they're piling up on top of one another, so you can't really tell the difference yet. But if you expand the tree view, you can see so far we've made 3 nodes. So we're halfway there. To color sphere, geo create node of type color, and you can specify a named parameter, in this case node name, to give the node that you create a specific name. Now, I made a mistake. I forgot the equal sign. There we go. So now piled up over there, and you can see the 4th node appeared over here. Next, we're going to create a merge node. Create node, and we're just going to call it merge 1. We won't give it a specific name. And lastly, we'll have the output node, which will be a null node. There we go. So we've created the 6 nodes over here that we'll be using. And right now they're piled on top of one another. There is, for the geo node, a function called LayoutChildren, a method. You call that and it will just rearrange them for you automatically. By the way, what's the error that we're getting on this color sphere? No inputs provided. That's okay. We'll be fixing that shortly. So let's go ahead and arrange these. Well, I'm not going to connect them because we'll be connecting them using Python as well, but let's arrange them how we want it to appear. The last thing will be the output. Before that, we're going to have a merge. We're going to have a box. We're going to have a sphere. We will have a color node connected to the box and a color node connected to the sphere. Let's put this in between. So this is how we would have wired them together. So how do we add the wires? Just as we saw that when you create a node, you have to create a node from its parent to guarantee that it appears over here. Now over here, the way you connect 2 nodes, this is different, is you have to specify what its input is. So let's take the null node, which we called output, sorry, and you call set input. What is the input to the null node? Parentheses. Whenever you see self, that just lets you know that you're calling a method on something. You can ignore that. The input index. There's only one input on the null node. Some nodes like merge or some of the dot nodes and what have you can have 3, 4, 5 input dots. This has only one. Nevertheless, we have to specify the index. And index is start at 0. And then you specify what node you want it to be. We want it to be merge. Now watch what happens when I press enter here. A wire should appear connecting merge to null. And it does. Now let's connect merge to the 2 colors. So we'll take merge and call set input. Now here there are going to be 2 inputs, color box and color sphere. So we'll first wire in the color box node. Wire appeared in the network editor. And now let's call set input again, this time with input index 1. and pass in the color sphere node. Wire made. We're getting close. So now we need to wire up the color box to the box node. So you take the output, in this case color box, and specify what its input should be. There's only one input, so we could pass in the input index of 0 and the box. And then lastly, the color sphere node, set the input to be the sphere. There we go. They're all wired up the way we would. And you can see it was a little more time consuming to do it by Python than by using your cursor and just wiring them up. But oftentimes, if you're working with hundreds and thousands of nodes and you're looping through and wiring things up, the Python will then become faster. Now we have a bit of a problem. Right now, box is set to display. We'd like the null node to be displayed. And then what we'll want to do is we'll want to move the two shapes so they're not on top of each other, because we can see the box but not the sphere. And then we'll want to give them some colors. And then I think you'll have an excellent feel on how this works. So let's change the display flag. So right now, box has both the render flag and display flags set to true. And we want to change that to the null node, or the output node as we called it. There's a method called setDisplayFlag. If you call that, it just wants a true or false. Let's say we want this to be the one displayed. If we press enter, now null is being displayed. And interestingly, now the sphere is kind of clobbering the box. Notice the box is still highlighted. That's because it has the render flag on. Let's change that to the output as well. So we will call setRenderFlag to true. There we go. Now let's move the box. Let's zoom out here in the viewport, the scene view. Let's move the box a little bit and also change the color of the two shapes. So for that, we will be changing some parameters. And we do have a separate lesson where we explore how to change and work with parameters from Houdini. So this will be a little bit of an introduction to you if you haven't seen it, or a recap if you have. So let's take the box. And the way you change its position is if you select the box, you'll see that it has a lot of parameters. These numbers over here are called parameters. In the geometry spreadsheet, they're called attributes. And we want to change the center, which has parameter names tx, ty, tz. So we are going to call set params, that's set parameters. And when you open parentheses, it lets you know what you have to specify. They want a dictionary mapping the name of the parameter to its new value. The names we saw were tx, and let's map that to, how about -2, and ty, which, how about let's leave it at 0, and for tz, let's do -1. And this is a dictionary which needs to be surrounded by braces, and now when we press enter, there we go. It moved the box. And if you look at the center parameter, you'll see the values are -2, 0, and -1. So we've now moved the box using Python. Next is let's actually specify what the color should be. So for the color box, if you look, there is a method called setColor. And when you open parentheses, it asks for a Houdini.color object. So let's do Houdini.color. And in here, they want a tuple with how much red, green, and blue you want. So you may think, well, let's make the box red. Kind of type in 1, 0, 0. But watch what happens. This setColor method is actually the color of the node in a network editor. It's actually not the color itself. Because remember, when you select on the color node, the color is a parameter. So let's just do Control-Z. And Control-Z again until the color goes away. So that's the little bit of a trick, is we need to take the color box and set the parameter values we want for the color. And when we come to the color box, you can see the 3 parameters controlling the color are color R, color G, color B for red, green, and blue. So if we want it to be red, let's do color R to be 1, and we'll leave the others. Actually, we want to set the others to be 0. Right now, they're all 1. So color G will be 0, and color B will be 0. This will make a pure red box. There we go. And now for the sphere, I just hit the up arrow to bring up the last command. Let's make it green. So no red, And for green, we want it to be 1. There we go. So we now change the color and position all using Python. There is one last thing I would like to show you, and that is suppose you would like to freeze this box. Normally you would come up here and click the lock, like you want to actually lock this node so it's not cooking all the time. How can you do that? So if we take box, is there anything dealing with cooking? Well, there is cook, but what this will actually do is force a cook or force a recook if you want. Is there a freeze method? There's not. So the way you want to do this is there's a method called setGenericFlag. So these nodes have lots of different flags around them, and different types of nodes have different type of flags. What they want you to do, once again ignoring self, is they want you to specify what flag you want to change and then its value, true or false. The flag they let you know must be a Houdini.nodeFlagValue. So if you type in hou.nodeFlag. These are all the different flags available to different nodes inside Houdini. And the one we want to do is we want to lock. The lock node will set it to true, and when I hit enter, what should happen on this box node is a little snowflake should appear to let you know that this node is not going to continue to recook. Whatever the geometry is in there at that time, it's going to keep that geometry. So this is a nice overview, and just to do a quick recap, tree view shows you parent-child relationships. A node can have many children, but it can only have one parent. Next is when you come to the network editor, you have input-output relationships. And nodes can have multiple inputs and multiple outputs. And when you create a new node, you need to do so from its parent by calling the createNode method on the parent of the node. And when you want to connect two nodes, you want to call the setInput node to specify for this node what input do you want to add to it. One final thing, and this is kind of like an advanced bonus, but I think it's worth talking about. Let's get the root node up here, this slash. So we're going to call that root. We're going to call the node method and /. So we now have the root node. From what we see here, there are 8 children. There is a method called numItems. This lets you know how many children there are. And there are 8. Okay, so let's go through and display those 8. For child in root.children, print a child. There's actually 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The one that shows up here that does not show up there in the tree view is Vex. And let's get a hold of the Vex node. Vex is /Vex. Notice it does not even show up in the auto-suggest. In the auto-suggest here, there are 8 contexts. And the one that's missing is Vex. So let's get Vex. So why is it not being displayed? And here's the reason why Vex does not appear in the tree view. For the Vex node, if you call the isHidden method, you'll see true, meaning that it's there, but it's hidden. Meanwhile, the obj node, if you call the isHidden method, it'll say false. It's not hidden, it's visible here. And when you go back and look at older Houdini tutorials, what you will see is that the tree view changes from version to version. For example, stage and tasks are relatively new nodes, top-level nodes here, contexts. Stage is where you do a lot of work with USD and LOPS. Tasks is where you work with task operators, TOPS. At version 17, there used to be a Vex folder, if you will. Version 17.5, that was taken away. And so it's still there, my guess is for backwards compatibility, but they're hiding it to let you know that that's really not the way you should be using it going forward. And in fact, in a lot of different contexts now, you can create VOP networks. You no longer have to put VOP networks inside the Vex folder over here. So if you were to explore starting at the top and go through and browse all the different nodes, I wanted to let you know that you might be surprised to find that the root node has 9 children, only 8 of them are visible. And that's the reason why.